Okay, today we're going to talk about measuring section 1.4, measures and classify angles. Pretty self-explanatory introduction to angles, which we're going to cover a whole lot over the course of this class. First thing, let's just jump right in to minimize the time here. The first thing we need to know is that an angle consists, according to your textbook, an angle consists of two different rays with the same endpoint. Okay, so one of your definitions you can add to your vocabulary notebook is an angle consists of two different rays with the same endpoint. What does that look like? Well, if I have endpoint A here, and then I have a ray, let's call it B. So this right here is ray AB. Okay, well, to create an angle, I might have another ray like so. This here would be ray, if I call this AC, ray AC. So ray AB, okay, connected with ray AC, they both have the same endpoint A, you notice there, those create angle BAC. Now the rays are the sides, so this is the ray. These are the sides of my angle. Okay, so ray AC and ray AB create a side of my angle. And then A, this is the vertex. Okay, the angle itself, which we'll measure later, lies right there, within there. Now notice how the vertex is in the center of the name of your angle. So based on that information, can I rename this? Based on everything you've learned so far about segments, endpoints, lines, and so on and so forth, how can I rename this angle to something else? And by the way, if you didn't recognize, this is the angle symbol right here. Okay, so what's another name for angle BAC? Well, how about angle CAB? Or if you even want to be more simple than that, you can just call it angle A. But notice the importance of the vertex in all three angle names. It's in the middle of the two other points when you talk about the three-letter angle name, or it is the only letter with the angle name. Alright, so let's look at another example. Let's say you have an endpoint here, then you have a side coming out here, a side coming out here, and a side coming out here. Let's clean up this endpoint. Whoop. So here's our endpoint, or our vertex. Here's a point. Here's a point. Here's a point. And we need to give these guys names. We'll give this V, S, T, and R. And these, of course, are rays, so they go on forever. So looking at this particular diagram, let's go ahead and name the angles that we see. The first angle you see might be SVT. So you see angle SVT. What's another name for angle SVT? How about angle TVS? Then you might come over here and say, okay, I see angle TVR. What's another angle name for angle TVR? How about angle RVT? Okay, do we see another angle? Okay, how about let me change the color real quick, sorry for the delay. How about this? How about angle SVR? So angle SVR. Another name for angle SVR might be angle RVS. So from here we found 1, 2, because remember these are the same, and these are the same, and these are the same. We found 3 different angles. Okay, 3 different angles out of this particular diagram with 6 possible names. Notice the one thing I didn't name this. Notice that I did not name this angle V. How come? Why didn't I name this angle V? Okay, if you're thinking to yourself, you couldn't name it angle V because angle V, how would you differentiate angle V being, is this angle V? Or is this angle V? Or is this angle V? Okay, they all have the same vertex, and since they all have the same vertex, you can't just distinguish one being angle V. You have to actually call them by their 3-letter name. So that's a brief introduction to identifying angles and naming those angles as well.
All right, the next thing I want to talk about is angle bisectors and congruent angles. Basically, it's just some more vocabulary that we can add, but an angle bisector is a ray that divides an angle into 2 congruent angles. As you can see here in our drawing, we have angle GHJ, and it is being bisected by a ray, and you can see that both angles are equal to 18 degrees, which would mean that the initial angle was 36 degrees. So, again, an angle bisector is a ray that divides an angle into 2 congruent angles. And just to review, a congruent angle are 2 angle measures that are exactly the same thing. All right, let's classify some angles now, okay? We got 4 primary types of angles that we're going to talk about. They are the straight angle, which is 80 degrees. 2 angles that are put together that create a straight line. Pretty self-explanatory. They look just like 2 rays going in opposite directions, or 2 opposite rays. A lot of times with our straight angle, you would have a vertex in the middle, and then 2 rays going in opposite directions. That creates that 180-degree straight angle. Then you have your obtuse angle. That's any angle that is less than 180 degrees, but greater than 90 degrees. You know, somewhere along the lines of 110 degrees, 150 degrees, stuff like that. Again, this should be pretty familiar to you when you're talking about, you know, obtuse, acute, and right triangles. You probably learned those in elementary, early middle school. So again, obtuse angle is your big angle, basically. And then you have your acute angle, which is an angle that is less than 90 degrees. Okay, so any angle that is less than a right angle is an acute angle, so it's the smaller angles. And then again, you have, last but not least, you have your right angle, which is 90 degrees. And again, you guys are familiar with that. It's got the special marking with that box that shows you that that angle is 90 degrees. There's some other angles that we're going to talk about as we move forward. One of those would be like an oblique angle. An oblique angle is an angle that is between 0 and 180 degrees. 90 and 180 degrees, that is not 90 or a multiple of 90 degrees. Again, that's something that we'll talk about in upcoming classes, and something that you'll kind of use Discovery to figure out more of. Not something that we use a great deal of, but it's information that's that you'll need to know. Two new postulates, yay! Okay, we're going to talk about 2 new postulates that your textbook goes over. These still frames actually come straight out of the textbook. First one is your protractor postulate. Basically, it is telling you that you can use a protractor to measure your angle. This postulate, as is written in the textbook, is kind of complicated, but it says consider ray OB and point A on the side of OB, ray OB. The rays that form ray OB can be matched to one another with real numbers from 0 to 180. The measure of angle OAB is equal to the absolute value of the distance between the real numbers for ray OA and ray OB. Again, it's an absolute value. You're not going to have very many negative angle measures, at least at this early in the stage. So Basically what it's saying is you could take the distance between the one ray and the other ray, that little arc angle, if you will, and that's how you figure out what the actual angle measure is. Just the absolute value of that, meaning it's going to be a positive number. In our next postulate, postulate number 2, or actually postulate number 4, our second one in this series, is the angle addition postulate, very similar to the segment addition postulate. Basically, it's just saying that if you look at this picture here, that angle RSP plus angle PST equal angle RST. So you take two angles that are maybe bisected by bisecting ray, or you take two angles that are together and you add them together and you can get that whole large angle. So again, you can read the postulate for yourself, but in easy terms, you just add two angles together that are touching each other, that share a common ray, and they will give you the total of the greatest, the larger angle. Pretty self-explanatory. And as always, if you ever have any questions, please ask me in class or in tutoring.
Okay, just a second ago we talked about the protractor postulate, which basically tells us that we can use a protractor in order to measure our angle measures. So we're going to go ahead and put that into practice to see what that looks like, and just practice using our protractor, because we'll do that a little bit this year. So the question that we have right here in front of us is, what are the following angle measures? Measure of angle SWA, the measure of angle AWG, and the measure of angle SWG. So if we come down here and look at our angles that are together here, you will notice that SWA, which is the first one we're looking at, is right here. Here's SWA, okay, and AWG is right here, okay, and then SWG is here, okay. So let's start off by taking our protractor, and every protractor is a little different, and we'll set the protractor, that circle, on the vertex, and then you want to line up your bottom line, or the bottom line ray, or the bottom ray of your angle, with the line on the bottom of your protractor. Now, notice that you're going to notice that your protractors are a little different. Each protractor is a little different. Let me just kind of explain how this works. So I told you already that your vertex goes right here in that circle. Now if you notice over here, you have a 0 on the outside edge of your protractor that starts the 0. When your ray is going in that direction, pointing at that 0, that means you use that outside edge in order to measure your angle measure. Okay? If your ray, the bottom ray of your angle, is going in the other direction here, okay, you're going to use the inside edge. Some of your protractors have a 0 on that inside edge, so that it tells you to measure the inside edge. So let's go ahead and get started. Let's do our first one, which is SWA. So SWA is this angle right here. Here's S, WA. W is the vertex. Okay. If we go from here, we look at our, not the bottom ray, but that other connecting ray, and we look out here, and we'll see that it goes to 133. Okay. 133 is our angle measure, because again, this bottom ray is pointing to this 0 here, so we're going to use the outside edge as we go around. We get to 133. Is that logical? Based on what you previously know with angle measures, you understand that 133 is an obtuse angle, an angle greater than 90 degrees. And again, we write in degrees. So that is a logical statement that that is 133 degrees. So now let's look at AWG. Okay, AWG is right here, AWG. Now the ray is going the opposite direction, so we're going to use that inside angle measure in order to determine our angle measure. So we go not the bottom ray, go to the other ray here, and we look at this other ray right here on the other side of the angle, and we see we're at roughly 43. Be careful that it's not 53, because you'd read right to left here. You're actually going the other direction, 40 to 50, so that must be not 43, excuse me, 47. Okay, 47. So angle AWG is 47 degrees. Okay. Now we can do one of two things with the SWG. I'm going to go ahead and remove the protractor from here for us to see. Okay. When we look at our angle diagram again, SWG is clearly a straight line, okay? Or a straight line angle is what we learned about earlier as well. So that is clearly 180 degrees because we know it is a straight line angle. So it's 180 degrees, not 1800. That is a degree sign. Okay? Now, the other thing we can do is that if we know that this angle right here is 47 degrees and this angle right here is 133 degrees based on our protractor measurements, we can now implement another postulate that we're going to talk about, which is angle addition postulate. Okay, so the angle addition postulate, or the AA postulate, okay, basically states this is how I proved that I'm using this. I'm going to say the measure of angle SWA plus the measure of angle AWG is equal to the measure of angle SWG. Okay? Does everybody see that? So SWA combined with WAG will get this whole angle measure. Okay, so then if I just plug in what I know that SWA is 133 plus AWG is 47. 133 plus 47 equals 180 degrees. So we know it's a straight line angle because we can see that visually. We see it looks like a straight line angle, but we can also use our angle addition postulate in order to prove that it is actually a straight line angle using our measurements from the protractor postulate. So there we incorporated both of our postulates to figure that out.
And that's all, folks. Again, I wanted to remind you that this is not the end-all be-all. If you have more questions, refer to your textbook or come see me before or after school in tutoring. See you tomorrow.